Hello everyone, today my group is going to talk about the tooth formation. My name is Lin. I will analyze the tooth development and the eruption. Here will explain the common dental defects, and Lisa and Cynthia will describe the histologic structure of alveolar bone and its remodeling and regeneration potential. Tooth development starts from the crown formation when inner enamel epithelium, or IEE, in the bell-shaped enamel organ grow more columnar and differentiates into preamyloblasts. After that, the outer cells of the dental papilla are induced by the preamyloblasts to differentiate into odontoblasts, and it begins dentinogenesis, which is the opposition of dentin matrix or predentin. So the basement membrane between the preamyloblasts and the odontoblasts now disintegrates, allowing the preamyloblasts to come into contact with the newly formed predentin, and this induced the preamyloblasts to differentiate into amyloblasts, which is the enamel forming cells. Amyloblasts then begin amyogenesis, or the opposition of enamel matrix. After the crown formation has completed, root formation is then begin. Root dentin formation is actually similar to the dentin formation in the crown portion. So let's discuss the formation of cementum in the root area. So the cementoblasts move to cover the root dentin area and undergo cementogenesis, laying down the cementum matrix. So many cementoblasts then become entrapped by the cementum they produced and become mature cementocytes. As the cementocytes become calcified, it is then considered cementum. And also at this time, the central cells of the dental papilla are also forming into the pulp. Now let's look at the tooth formation. So after enamel opposition has completed, the layers of the enamel organ are compressed, forming the reduced enamel epithelium, or REE. So the REE first has to fuse with the oral epithelium lining the oral cavity. Then the enzymes from the REE then disintegrate the central part of the fused tissue and leaving an epithelium tunnel for the tooth to erupt. Lastly, as epithelium actively erupts, the coronal part of the fused enamel tissue peels back off the crown, leaving the cervical part is still attached to the neck of the tooth, just like peeling the banana.
Talking about dental defects. Well, to talk about defects that related to enamel should have a dancing dent. In this case, the enamel will invaginate into the dental papillas, and it usually happens during the cap stage. The second one is the tubercles, with the formations of the extra cups on the dentitions. This is due to the faulty development during the enamel organs. Now I'm going to talk about the defect that related to the faulty developments of the amyloblasts. The first one with the enamel pierce. This is how it looks like on the X-ray in the normal ones. The next one is the enamel hypoplasias and the enamel hypocalcifications. This is called the change in color, deep-fittings, or the thickness of the enamels. And the defect is important to know because it's contributing to the local contributing factor that affect oral health, and it can cause difficulty to cleaning the teeth at home and also for the clinicians because it can faulty recognize the tubercles and the extra cups at the calculus. Next is the defect related to the dentin, such as the dentinogenesis imperfectus. It's called the blue prayer brown teeth with an apoptosis on the patient's teeth, and it can affect the patient's confidence about their smile. Now we'll talk about defect related to the root, pulp, and cementums. The first one is the germinations. We develop a black single root with one pulp cavity and twinnings. This is how it looks like on the X-ray and on the gross sections. Another one is the coalescence, which is the union of root structure up to or more teeth by the cementums, and it is usually caused by the excess cementum developments. Next one will be the fusions, which is the union of two tooth joints. So in this case, the graph will look bigger, but actually a two tooth with two different bulbs. And lastly, the diagram that will help you go to differentiate between gemination, fusion, and coalescence.
So I will be talking about the histological features of bone. There are two types of bone, compact bone and cancellous bone. Compact bone is more dense and cancellous bone is more soft and spongy. Both compact bone and cancellous bone can be found in both your long bones and your flat bones. And cancellous bone and compact bone have the same cellular features, but the cellular features are arranged differently. So here, there's a picture of our mandible that shows the cancellous bone and the soft, which is a soft, spongy bone located on the alveolar bone proper. So bone is made up of 6% inorganic material with three main cell types. There are other cell types associated with these three main cell types. The associated cells are fibroblasts and mesenchymal cells. So the fibroblasts differentiate into mesenchymal cells, and then the mesenchymal cells differentiate into the osteoblasts. The osteoblasts are the main components that distribute the bone matrix. So here you can see the osteoblasts are on the surface of the bone, and the osteocytes are trapped within the osteoblasts. So once the fully mineralized osteocyte is fully mineralized, then it is considered the osteoblast. Here you can see the osteoclast. The osteoclasts are cells that are responsible for breaking down bone and allow remodeling and repairing of bone. So it's important to know that there are two different ways that bone can grow. Bone can grow by endochondral ossification and intramembranous ossification. Endochondral ossification is, so what happens is the osteocytes are trapped inside the hyaline cartilage model and they eventually die. So here you can see the steps of the hyaline cartilage model being grown in long ways, and the osteocytes are trapped inside and then they eventually die. As for the intramembranous ossification, the osteocytes are between two connective sheets, but they don't die. They are still there. So here you can see the connective tissue on top and then the newly mineralized bone on the bottom, and then the osteocytes are trapped within the lacunae in between. So here you have intramembranous ossification, and here you have the endochondral ossification, and here you have the osteoclast, and here you have the osteocytes within the osteoblast.
Hello everyone, my name is Cynthia and I will be talking about the regeneration and remodeling of alveolar bone. So we begin with the remodeling of alveolar bone. It is a process in which deposition and bone resorption occurs, and it is done by osteoblasts and osteoclasts. So the beginning stage is activation, which is cells from the blood form mature osteoclasts, and the active osteoclasts then break down the bone. Mononuclear cells pick up the cells and then transfer it into the reversal stage. Then macrophages pack the leftover extracellular matrix. And after that, pre-osteoblasts are formed, and which leads to the fourth phase, which is formation, where mature osteoblasts lead to deposition of organic matrix. And then the final stage is when there is mineralization. So hydroxyapatite crystals are mineralized for the new cycle of remodeling and bone formation. I just want to mention that this entire process is done within the period of 17 weeks of duration, and remodeling of the bone is affected by hormones and as well as age. So the older we get, the slower that this process does become. Ways that remodeling of the bone takes place. So we have orthodontic therapy as well as physiological drift. So what happens when in orthodontic therapy is that there is a compression zone and tension zone. So in the tension zone, there is bone deposition, and the compression zone, there is bone resorption. This is all caused by the pressure that is caused by the bracket. Just think of it of a rubber. So the tension zone kind of stretches out into where the tooth wants to move, and the compression zone is where the ligaments are pulling it towards. So this tooth is going mesial, and then the same occurs for physiological drift, especially after a tooth extraction. Here are our references, and that is it. Thank you very much. Thank you guys for watching.